Hello everyone. Now we'll see the construction and working principle of microwave phase shifter. Phase shifters are the devices which will change the phase of the incoming signal without altering its magnitude. RF phase shifters are used to change the transmission phase angle of the input signal. Ideally, phase shifters does not introduce any loss in the input signal, but there will be some amount of loss whenever the phase shifter is introduced in the RF network. That loss will be considered as an insertion loss. There are three major types of phase shifters are there. One is non-reciprocal latching phase shifter. Second one is Faraday rotation phase shifter. Third one is pin diode phase shifter. The non-reciprocal latching phase shifter consists of a toroid ferrite core symmetrically located in the waveguide with a bias line passing through its center. Whenever a current is applied to the bias line, the ferrite core is magnetized. The magnetization of the ferrite core will change the phase angle of the input signal. The amount of shift in the phase angle is directly proportional to strength of the magnetic field. That magnetic field strength actually proportional to the amount of current which is applied to the bias line. This configuration can be used to provide continuous amount of phase shift by varying the bias current. Initially, when there is no bias field, the ferrite core is not having any magnetic field. Due to that, there will not be any phase shift in the incoming signal. Whenever a bias current is applied, the magnetic field of the ferrite core increases linearly. After a certain time, it reaches the saturation value. Even though when you remove the bias current, the magnetic field remains in the saturation state as long as you apply the current of opposite direction. Using non-reciprocal latching phase shifter, we can able to achieve different levels of phase shift. In practice, several sections having individual bias lines and variable lengths of ferrite core, we can able to achieve various phase shifts like 180 degree, 90 degree and 45 degree, etc. By applying bias field in opposite direction will remove the remnant magnetic field in the ferrite. There are several advantages associated with the non-reciprocal phase shifter. First one is bias current does not to be applied continuously. One pulse is enough to provide the continuous amount of phase shift. Second one is switching speed of the non-reciprocal phase shifter is very high. That means we can able to achieve the phase shift in the order of few microseconds. The Faraday rotation phase shifter consists of rectangular to circular waveguide transition in the left hand side, circular waveguide in the middle and circular to rectangular transition in the right hand side. Two quarter wave plates and one ferrite rod is placed in the circular waveguide section. When a wave enter into the rectangular to circular waveguide transition, TE10 mode of the wave will be converted into TE11 mode, and then a quarter wave dielectric plate will convert linearly polarized wave into circularly polarized wave, and a ferrite core which is placed in the center of the circular waveguide will introduce a phase shift in the signal. The amount of phase shift is controlled by using the bias field strength. Then second quarter wave plate will convert the linearly circularly polarized wave into linearly polarized wave. Then circular to rectangular waveguide transition will convert TE11 mode into TE10 mode. In pin diode phase shifter, different levels of phase shift can be obtained by directing the microwave signal through two different paths having different lengths. That amount of phase shift is directly proportional to the length of the path. The advantages of pin diode phase shifters are small in size, easy to integrate with planar circuits, and high switching speed. The disadvantage of pin diode phase shifter is power requirement is high. This one is undesirable characteristics where power constraint is very important parameter.